Hi all, this is VLSA updates. In this session, I just wanted to create one design requirement and see how effectively we can understand the requirement and create a low-level architecture for that, and take it through the any of the design flow. Like it can be ASIC, it can be FPGA. So let us see that basic requirement and how this can be created through the design flow. That's a primary goal, and I just created simple basic design, and I just wanted to share it with you all so that it will be helpful, and you also can point some suggestions on that how it can be take it up and how it can be done. And also let me share you that. Yeah, so we have the data which is coming from the external world. Let me just create that. Let me just put a environment. Let's assume we have the FPGA world. Okay. Okay, so let us assume there is a data which is coming from the external world. It can be any sensor, it can be any analog devices. Okay, any analog data can come, and there is assume there is a analog to digital converter, some external data from some sensor, some let me make that point. mm, yeah, let me take these things. Some external sensor. Okay. Okay, some external sensor, just assume the external sensor which is data is coming in the raw form. Okay, so this data will get converted in digital form. Eventually it will enter into FPGA, right? FPGA cannot process the analog data format, so we need to convert this data into the digital format. Let's say we have some ADC kind of thing here. um, let's say, let me put some kind of ADC processing. So after the ADC processing, we have this FPGA platform here. So let me mention that. So this is my FPGA, and yeah. So the moment data arrives in an FPGA, okay, just assume there are streaming of data, okay, but we have the only one interface, which is the ADC interface, and ADC can have the serial line. Okay, data line will be there. You can assume like 12 bit or 14 bit or 16 bit of ADC data is coming. Okay, so we need to stream that data into our FPGA. So how do we do that? Okay, so for that we need to make some storage here. I'm just assuming some storage kind of things here. Let me just mention that. Okay, let us decide what kind of storage we can go for it. Okay, depends on the streaming capacity, but anyway we have to go for some available FPGA resources on the FPGA board. Okay, which is easier and easy to access also. We can't go for the external memory interfaces like DDR or something at this moment. Okay, we should try to use the available on-chip memory resources. We can call it as a block RAM or ultra RAM, or distributed RAM we can try, but if the capacity is more and we cannot use large number of registers for that. So that's one thing. So let us assume block RAM or FIFO. FIFO again uses the block RAM, so we can call it as FIFO here. Okay. So in this stage we are going to do some data processing. Depends on your application. Let's say if you are doing some image processing, you have to do some image processing here. If you are doing some machine vision or the computer vision, you need to write some algorithm for that. If you are using some a signal processing application, you have to do for some filtering on that, where you wanted to modify the data, right? So like optimize the data. So we can mention multiple processing here, like filtering or image processing, signal processing, image processing, whatever the application you use. Okay. signal processing and image processing, computer vision or machine vision, whatever it is. Machine vision application. Okay, so based on the application, the signal processing things changes. Okay, let us decide that what kind of processing we are trying to do. Yeah, let me put this way. So once you're done with your processing, so here only we need to estimate the logical resources are going to be consumed. It depends on the algorithm. And how do you do that manual logic resource estimation is like you need to draw the microarchitecture for the same and understand how many bits of data you're passing. Suppose if you're doing some FFT kind of thing, and you should know the FFT IP estimation for that. Let's say if you're using some radix 2 or radix 4 FFT IP, you should know the FFT IP logical resources consumption. It can be the some third party IP, or it can be the IP which is already available in the FPGA itself. Okay, so in that case it is very easy for us that we can use the estimated resources which are already optimized in the environment. Okay, so that would be easy for us. So how many IPs we are going to use, and do we need any kind of intermediate logic for that? So based on that we can calculate everything in the ground. Okay, so that's how this processing happens. And again, before we sending into the external world, let's assume here is your FPGA sending. Okay, let me put the FPGA here. Yeah, let me put the line here. Let me put the line here. Okay, so this is my FPGA area. It's going to end here. So before sending it to the external world, and again I'm going to store it because the streaming might happen continuously. The data processing might give large amount of data which I cannot directly pass it to the external world, or I might use some of the data. So in this case, suppose you feel like your processing is taking a large number of data. Okay, when you continuously pass the streaming, okay, we might have to go for some external interface also, like DDR memory for the large amount of memory here. Let me choose that, just keeping it for the reference. Just moving this. Let me do that. Suppose in some cases we might need some external memory. It's the DDR memory. I'm just keeping it outside because the memory will be in outside only. Just keeping it outside. In some processing cases, you have to go to the external world and you have to come back to the FPGA. How do we do that? You can create some memory controller. Again, you have to estimate the resources for the same in the ground and how it's going to be calculated and all. Let me add that. Yeah, DDR memory controller. Let me mention like memory controller. Okay, so here there is memory controller. Yeah, okay. Yeah, I'm just giving the memory controller here. Sometimes you have to connect to that. Yeah, so then it has to go to the external DDR memory interface and then come back from there. Okay, let me mention that way. External interface, which is the DDR interface, and let me try this one. Yeah. this will represent my external interface, and I have the memory controller here. So this is data processing which is communicating this memory controller now, right? So again I can bring it back here, but I can do it in this format. Yeah, okay, this will go to this. Okay, I can mention this way also. Instead of going through this, I will go to my DDR controller, and yeah, yes, yeah, this is the only way we can do it. Okay, let me go through this way. Yeah, so instead of directly going through the Steam data output, we are just going via some external DDR memory. Okay, so due to the large memory processing here, large data processing here, so in this case we might have to see a lot of latency, throughput, so will be happening in this area. Okay, so once the data is available, we can store it in the external some internal FPGA resources again. Again, we are not going to have the entire data at the same time, so we will read whenever the data is available here, and that will be given to some DAC, because we already having the format in digital format. We will convert them into the analog format. Let's call it DAC. Okay. Let me mention the DAC here. So DAC will give the information on that, and you can give it to the external world here. Yeah, this is what I wanted to cover. So let's just work on it and see how do we estimate the resources and all here. Okay, that would be more interesting in this case. Okay, hope it's interesting. Let's connect more. Thank you all. Bye.